Now we will learn about the three equations of motion. This is the heart and soul of kinematics, and you will rarely find a problem which does not use one of these or a modified version of these equations. But in a better problem, you may not be able to use these equations directly. For example, when even the acceleration is changing with time. Here you will have to get back to the basics of how you arrived at these three equations and modified it accordingly to the problem at hand. We will explore that when we get into solving problems. But for now, let's hear from physics god. Using these equations, you should remember what these alphabets mean. Then notice the number of variables in each equation. In most of these problems, you will be given the value of all these variables except one. You have to plug the rest of the values in the equation and find the unknown variable. It's as easy as this. Then let's talk about an object undergoing motion under gravity. Body undergoing motion under influence of gravity has an acceleration of g in downward direction.
So what should be the sign of g?
For the sign of the state variables, we will follow our usual sign convention, taking up as positive and down as negative. Before going into mathematics, we will try to understand the physics behind the equations of motion. These equations of motion only talk about motion under constant acceleration. Velocity versus time graph for a body moving under constant acceleration will be a straight line, that is essentially a curve with a constant slope. The first equation is used to find the change in velocity in a given time interval. Let's look at this graph. Here we know the slope of this curve gives us the ratio of change in velocity and the time interval. This is how we know the relationship between the change in velocity and the time interval. So, if we know the time interval, we can find the change in velocity, which will be time interval into acceleration. And if we know the change in velocity, we can find the time interval by dividing it by acceleration. The other information we can obtain from this velocity versus time graph is to find the area under the curve in a given time interval, that is to find displacement. By simple geometry, we know the area of this rectangle is u into t, and this triangle is half into base into height. The base is the time interval and the height is the change in velocity, which we had already established is equal to acceleration into time. This gives us second equation of motion, and we use it to find displacement using information about velocity and time. The third equation doesn't have much physics in it and mostly is mathematical manipulation of the first two equations. Things you can do using this equation can also be done using the first two equations, but would require an additional step. Here essentially we are eliminating time factor to find relationship between velocities, acceleration and displacement. So now we will examine a simplest case of motion under gravity, where we will release a ball from a height h from the ground. Now because the gravity is in downward direction and we have considered down as a negative direction, the slope of this v versus t graph would be downward and the initial velocity is 0 in our case. By analysis we can find two informations. The first is the time it takes to fall 1 meter and the velocity when it hits the ground. Here the displacement is in downward direction, hence s is -1. The point of time when the area under the curve becomes -1 will be the time when it reaches the ground. Now that we know the time of flight, we can also find the final velocity by multiplying acceleration with time. Tell me, if you directly had to find the final velocity without first finding the time of the flight, how will you do?
I'll use this equation. Yeah, it is easy. Let's try something else. Let's throw it upwards.
Fine. Here the initial velocity is in upward direction, hence positive, and it constantly decreases due to negative acceleration. During the flight, it also passes a point when its velocity becomes 0, which coincides with the highest point of its flight. Again, looking at this graph, things we can find out are time when the velocity becomes 0 and the height it reaches at that point. We know the change in velocity at this point, hence the time. And as we know time and change in velocity, we know displacement too. Remember, this displacement is from initial position and that is starting point. If you are asked to find the height from the ground, you will have to add this 1 meter also. Well, that was about it. But additionally, you should know that the sign convention we took is not a hard rule. We could have taken downward direction as positive and accordingly the displacement